As you transition to some upper level math, a thing that becomes pretty important is understanding interval notation. Try to get away from writing inequalities and instead use notation to interval notation to represent that solution set. So I think looking at the second and third column here, the inequality in the graph, you could probably go through and make a graph for all of these inequalities. If I knew that x was between a and b, what I would know is, and not including a or b, you would say, well, I've got an open circle at a and an open circle at b, and my solutions are in between. Right? This is something that you've done a long time ago. Whereas the next one, I would have closed circles at a and b, right? Because I have that it can be a and it can be b, and my solutions would be in between, right? The next one, I'm going to skip the graphs of those, but the next one I would have a closed circle at A and an open circle at B, and then vice versa, flip that for these because I have not equal to A and I do have equal to B. The idea is, if I want to represent these numbers between A and B, instead of writing it like this, what I can do, and at first it's going to kind of look like a coordinate point, I can just say that all of my numbers are in between A and B. So I'm going to say parenthesis A comma B. Now again, that gets confused a lot with a coordinate point, A comma B. That has absolutely nothing to do with the coordinate point, whatever that would be. Okay, A comma B. That is not the same thing. We are saying an interval. We're going to say all the numbers between A and B, and those parentheses say not including A and also not including B. We're strictly between A and B. If I can include one of those endpoints, so the very next one I include both. I include both A and B as possible solutions as well. I simply just change those parentheses to brackets. And that is the interval from A to B, including both A and B, which means that those endpoints can be included in our solutions. So the next two, the next one I include A. I have or equal to A, but I cannot include B. So I simply have a bracket on A and a parenthesis on B. And then the one after that, I don't include A. I do include B. Scrolling down, those are the only ones where I have endpoints on both sides. Our values, our numbers are strictly between two numbers, between A and B. Okay. When I get down to this next one, I've got, okay, x is greater than A, so what would that mean? Well, I would have an open circle at A, and you would just draw this arrow off to the right, right? It would be any number bigger than A. Or the one after that, I would have closed circle at A, because I can include A, but again, that or any number bigger than A. And then the opposite here, if it's less than, I would go to the left with an open circle on the first one and a closed circle on the second one. So before I get to that last one, I'll talk about these four. If I were to write this interval, like what I want to think of it as is what is the very smallest thing in my solution set and what is the very biggest thing in my solution set, right? So our smallest number in our solution set for this first one at the top here, the very smallest thing that it could be is A, but it can't be A, right? It's a parenthesis, it's a boundary. It doesn't go below A, but I also can't include A. So I start at A, and then where does it go? Well, it goes off to the right forever, which means that it ends at infinity. But the thing is, with infinity, I'll just always remember this, you can never include infinity. Never put a bracket with that, because you can't really say infinity is included in my solution set, because you could give me a number bigger than whatever the infinity is that you're thinking of, right? It keeps on going, so we can't actually include that in our solution, but it is our boundary. I have a right boundary there at infinity. The very next one is the same, except I can include A. So I do a bracket with A. I still do a parenthesis around infinity. Okay, now the next two, the biggest thing that we can have is A, right? The solution set stops at A if I'm thinking left to right. So my endpoint of my interval on these two is A. I can't include A on the first one. I can include A on the second one. Small thing here that you got to think about. What is the very smallest thing in my solution set then? Well, if it goes off to the left forever, the very smallest thing, the left endpoint of my solution set is not infinity, because when you say infinity, you're saying a positive infinity, which is not the case here. It is negative infinity, right? We go off in the negative direction forever, and again, I can't include that, so it's going to be a parenthesis. And then the same thing on the one below that. And then the last one is all real numbers. You probably had this once or twice in an Algebra 1 class where you had to graph all real numbers on a number line, and that means I just basically recreate the number line. Like anything at all on here is a solution, so all of those things are solutions, which means my lowest solution is negative infinity, and my biggest solution is positive infinity. Again, making sure I put parentheses around those. So you will never have anything in interval notation that looks different than what I've given you right here in this first column. So make sure you understand the difference between a parenthesis and a bracket. Make sure you know the order in which to write those numbers. It's very important, and again, make sure that you don't get that confused with a coordinate point. It has absolutely nothing to do with a coordinate point. Okay, so interval notation, pretty important thing as you transition to advanced math.